Okay, we're in lesson 4 today. We're talking about the algebra of matrices. Remember, a matrix is a rectangular array of numbers written within brackets, and we usually name those matrices with capital letters. In this example below, you see that A is a 2-row by 3-column matrix, and we said earlier that we could say that this is a 2 by 3 matrix. And any m by n matrix with the same number of rows as columns is known as a square matrix. And again, below, we've seen this before in our earlier lesson. This is the identity matrix, where the diagonals from top left to lower right are all ones in that diagonal entry, and all the other entries are zeros in the upper triangular and lower triangular section. So let's say we had the sum and difference of two matrices. If you have matrices of the same order, then you can add and subtract those matrices by matching up their corresponding elements in each row in each column. But the matrices have to be the same size. So here we're going to practice that with a 3 by 3 square matrix A and B. And if we find the sum of A and B, then we're taking row 1, column 1, and matrix A and adding row 1, column 1 from matrix B. So we have to match the corresponding elements. And following that procedure, we would get 2 and 5 is 7, and moving across to the next element, 4 and negative 2 would add up to be 2. And then negative 3 and 0 is negative 3. And moving on to the second row, we're going to find 3, 6, and 10 for row 2. And then moving on to row 3, we have negative 2, 3, and negative 4 for that particular sum of the two matrices. On example B, we're going to find the difference between the two. So the same thing, just be careful with the signs. 5 minus 2 is negative 3, and 4 minus negative 2 is positive 6, and negative 3 minus 0 is negative 3. And continuing matching up each element from matrix A with its corresponding element in matrix B, and taking the difference between the two, your final solution for the difference of matrix A and matrix B would look like this. So that's pretty straightforward. Now, the operations using matrices, we also have, let's say for 3 matrices, A, B, and C, if the matrices are order m by n and they're the same size, then the commutative property holds for the sum of two matrices, and the associative property holds for the sum of 3 matrices, and the 0 matrix upholds. A plus 0 is going to give us matrix A, and then scalar multiplication is similar to distributive property. If I multiply any matrix sum by a constant number, I can multiply the constant times matrix A and the constant times matrix B, and then do the sum as we've just seen. So let's try a few scalar multiplications. Here we want to find 2A minus 3B. So looking at 2A, multiplying this matrix by 2, so I'm going to multiply every element by 2. We're going to have 10, 2, 6, 12, 0, negative 4 for 2 times matrix A. Then we want to subtract 3 times matrix B. So 3 times each one of these is going to give us 0, 6, 12, negative 9, 3, and 24. Now, putting that together, I'm going to move this piece here. Putting that together, we would have 10, negative 4, and negative 6, and then 21, negative 3, and negative 28 for our final 2a minus 3b. Now, if it helps you, you could change this addition and go through and distribute the negative sign to each one of those elements, and that may help you ward off any errors there. And then on part B, we want a fourth of matrix C. So matrix C, let me see if I can shrink this down a little bit. Matrix C is a 2 by 2 matrix, and we want a fourth of that. So that's like dividing each term by 4 all the way across, which would give us 12 divided by 4 and 0 divided by 4, negative 4 divided by 4, and 8 divided by 4. So that's pretty straightforward with each one of those. Next, let's look at multiplying two matrices. And I believe on your notes, you've got to fill this in. So when we have a row by a column matrix multiplication, it's defined as a single number. So I've got one row and one column. I'm going to multiply row 1, the element in row 1, by the element in column 1. And then we're going to add them up to get that new element. So remember, the columns of A have to be equal to the rows of B. Otherwise, you cannot multiply two matrices together unless they have that property. So here we'll give this one, a simple one, a try. So I've got to multiply R by C. So row R by C, row by column. So I've got row 1 times column 1 plus row 2, plus row 1 element 2 by column 1 element 2, and then row 1 column 3 by column 1 element 3, row 3. So the row by the column is going to be a single number, 6 minus 24 minus 20. So adding those up looks like, what, negative 38, 44, negative 44 plus 6. So we got a row by column. Now, when that gets a little more complicated and we have 2 rows by 3 columns, so we've got a 2 by 3 matrix, and we're going to multiply that by a 3-row, 2-column. You see how these two inner things work? This is row, column, row, column. So the column in the first one has to be equal to the row in the second one. Then we can multiply them. Okay? So I like to use the highlighter here, and I'll show you why if I have that row and this column. So we can use those as kind of a highlighter for what we're going to do. So we want to multiply 3 times 2. So I'm looking at this element and this element. 3 times 2, and then 1 times 1, and then 2 times 3. And that's going to be the element or the number or the answer that we'll have in row 1, column 1. Now, move these little things out of the way. If I want to know the elements in row 1, column 2, then we're going to just repeat that process. So in row 1, column 2, we'll have 3 times 0 plus 1 times 1 plus 2 times 2. And then we're going to move this back to column 1 and this down to row 2. So all of the numbers, the sum of the products that go in row 2, column 1, will be negative 1 times 2, positive 1 times positive 1, and 0 times 3. And then our last multiplication is row 2, column 2. So that would be -1 times 0 plus 1 times 1 plus 0 times 2. So there we have the elements for our product. So this is going to be row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. So the product of matrix A times matrix B is this final solution. Okay, let's try this again. So we want B row times column A. Got to pay attention. So 2 times 3 is 6, and 0 times -1. Then we'll just work with row 1. We have the second column is 2 times 1 plus 0 times 1. And then we have the third column, which is 2 times 2 plus 0 times 0. So this is the first row. Now we're going to go back to column 1 and go back to row 2. So 1 times 3 and 1 times -1. Moving over to column 2, 1 times 1 and 1 times 1. And then moving to column 3, 1 times 2 and 1 times 0. And then we'll take this back to column 1 and go down to row 3 and repeat that 3 times 3 and 2 times -1. Moving over to column 2, 3 times 1 and 2 times 1. And finally moving over to column 3, 3 times 2 and 2 times 0. So our B times A product, row 1, 6, 2, and 4, row 2, 2, 2, 2, and row 3, 7, 5, 6. Okay, so I had a little rough start there. Have to pay attention. We're multiplying B times A. So the 3 row, 2 column, and the 2 row, 3 column have to match the columns, and the rows have to be the same to multiply. And then in our last one, we have an application. We have a citrus grower, has oranges and grapefruit trees in their groves, and they ship the citrus to 3 different packing houses. We've got a table that shows how many bushels of each fruit are shipped to each packing house. Profits for oranges are $8.25 a bushel, and profit for the grapefruit is $12.50 a bushel. We want to find the profit for each packing house. So we have to be careful what we're going to match up. So I'm thinking if we have $8.25 a bushel for the oranges and $12.50 a bushel for the grapefruit, then we need a matrix that has 2 rows. So that would be our table here, 125 and 100, 150 and 75, and 175. Then using the highlighter approach, if I have this much for the price per bushel and multiplying by this column, you can see that we're multiplying the profit for the oranges times the oranges, and the profit for the grapefruit times the grapefruit. And that's going to give us the right pairing for each of these elements. in our table or in our matrix multiplication. So we need a calculator to do 825 times 125 and 1250 times 100 for that first product. And then moving this over to the second column, we would have 825 times 150 and 1250 times 75. Ooh, and I write too big for this. Then moving over to that third column, we have 825 times 100 and 1250 times 75. So those are the first row elements. Now moving back to the second column, let's see, back to our product, we want to add those up. So this is our matrix multiplication. And 825 times 125, that element is going to be 1062.50 plus 1250. This one is going to be 1237.50 plus 937.50. And this last element will be 825 plus 937.50. And then adding those up so that we know each of the profits. We got 2312.50 for this first element. This second element is 2175, and then the third element would be 1762.50. Now, what did we just find out? So the name of the packing house, the first one, was Halls. So the profit at Halls is $23.12.50. The second one was Florida Citrus. So this is the profit for Florida Citrus. And then the last packing house was Indian River Fruit. And we used matrices and matrix multiplication to find those profits. This was a quick, easy lesson, and you'll have a chance to practice on the homework. See you in lesson 5.